Hi, everybody. This is McLaughlin here. I am going to go over division with partial quotients, which is the division strategy that we went over today in class. So just if you're a student and you need some extra help, or if you're a parent trying to figure out what in the world partial quotients are, I'm just kind of throwing this video together of the same examples that we used in class, just for a little bit extra support. Please obviously email me if you have any further questions after this video, and give me your feedback. Let me know what you think. The first example that we're going to do for partial quotients is the same one that we did in class. We did 8,192 divided by 3. So 8,192 divided by 3. In 4th grade, we only do 1-digit divisors, and we only go up to 4 digits in our dividend. So you won't ever get anything larger than a number in the thousands place, and you won't ever have to be dividing by 2-digit numbers unless you just want to challenge yourself. After these strategies, I'm hoping that you'll be confident in your abilities to be able to go with larger numbers, though. First, before we start with our division, what we've been practicing in class, just to kind of get us a heading and get us started, is working on tic-tacs, which is just an organized way of getting the first 9 multiples of our divisor down on paper, so that that's not something that we're going to have to spend time thinking about every single step of the way. We'll get them out of the way, and then we'll have them there to reference as we need them. So we're going to start with our divisor of 3, and we're going to make a tic-tac for our 3s. So off to the side of our paper, wherever we can fit it, we'll make a tic-tac-toe board. And then we can fill in our first 9 multiples of the digit 3. So we have 3, 6, 9, 12, 15, 18, 21, 24, and 27. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, all done out already for us. Before we do begin, we are going to estimate, because part of our learning goal is that I can assess the reasonableness of a quotient, meaning we're going to estimate first, and then whenever we do get our final quotient, we're going to make sure that it's reasonable depending on whatever we estimated for. So our estimate for this problem right here, we're going to need to find a compatible number. What we've been doing in class is looking at just the largest number and seeing if the divisor can go into it. Since 3 cannot go into 8, if you don't already know that, you can refer to your tic-tac, and 8 is not a multiple of 3. We did not list the number 8 on our 3 tic-tac, so we know that it can't go in evenly. So we're just going to pick the closest number to 8 that we do see on our tic-tac. In this case, that would be the number 9. So we'll use 9 as a compatible number. So instead of thinking of an 8 here, we'll think number 9, because we know that 9 is the 3rd multiple of 3. So we're going to say that the compatible number for 8,192 is going to be 9,000, since it's still going to be in the thousands place. So we'll think 9,000 divided by 3. So our quotient should be about 3,000, because we're taking 9,000 and dividing it by 3. So that'll give us our estimate, so that we can check the reasonability of the quotient that we do come up with at the end. So now that we have our tic-tac done, we have our estimate done, we're ready to start dividing with partial quotients. We are going to start writing our division problems Similar to the standard algorithm. And if you're a parent tuning in, I do just want to let you know what I've been telling the kids in class. If you're teaching your kids the standard algorithm or long division, as it's commonly known, and your kids are getting it, I'm so thrilled. I'm very happy for them, and that's great because it's a great algorithm to use. But in fourth grade, we do have to see that they know the strategies that are based on place value. So we did the area model last week. We spent Friday doing that one, and then we just started partial quotients today. We're going to spend the rest of this week practicing and doing some plug and chug methods of just getting some really good practice in with our place value strategies. I have to see one of them. I don't have to see both of them. So if they decided that area model was the most confusing thing and they could not stand it, did not like it, they don't have to use that one as long as they can use partial quotients, or vice versa. If they don't like this method and they do like the area model, they're more than welcome to use it. But I do have to see place value strategies at the fourth grade level for our assessments and for our formatives. That's just a side note. So when we go to set these up, it is going to look similar to the standard algorithm, where we will do 8,192, and we're going to divide that by 3. So same setup, we're going to be getting really close to long division or the standard algorithm. From here, it helps to kind of make a line going down. I always say it looks like that little hangman stand when you're playing the hangman game. So we'll hangman line it down, and then we're gonna create a list on the right side of this line for all of our partial quotients. So we're gonna make those listed right here to the side so that when we are done seeing how many groups of 3 we can subtract out of our dividend, we can just add these up. And as we're listing them on this side, we are always going to line them up vertically by place value. That way, when we're done, we can just go straight into the adding and we don't have to worry about rewriting them anywhere or making silly addition mistakes when we've done all this division beautifully. So the first thing that we're going to do when we get started, so in order to find our partial quotients, we're going to come over here and we're going to think how many times 3 can go into this 8 without going over. The easiest way to do that, if you don't know your multiples of 3 off the top of your head, just look on your tic-tac. Where should the number 8 go? We do know it goes between 6 and 9 on our number line. So we don't want to use 9 because that goes over our number of 8. So we're going to stick with our 6. We want a 6 down there. In order to get to this 6, we multiplied 3 by a number. We multiplied it by 2 to get to 6 because it's the second multiple of 3. So we did 3 times 2 to get to our 6. But this 6 is actually in the thousands place. We know that because we have this 1 place value holder, 2 place value holders, 3 place value holders. So we really have 6,000 here. So we didn't really do 3 times 2. We did 3 times 2,000. And we've really been working in class on balancing out our zeros, just kind of as a shortcut so that we know that we're in the correct place value. So we have 6,000 here. We got 6,000 here because we were able to take 2,000 groups of 3 away from this original 8,192. So since we're going to take those away from there, we are done with those. Subtract them on out. After we do our subtraction, column by column, no shortcuts here, we are left with 2,192. So then from there, we have our first partial quotient, and we have now a new dividend. So we're going to start it all from the beginning again. will go and look at the largest value again. And we're going to see if 3 can go into 2. Because 3 is already greater than 2, and we always say that for division, we don't want to go over. Even if we do 3 times 1, we'll be going over our 2. So we just move to the next digit over and include that one as well. So we'll look at 21. We want to know how many times 3 can go into 21 without going over. So if we look at our tic-tac, we see the actual number 21 on it. So we don't have to do the without going over with the left one. We can actually use the number 21. So we'll write 21 underneath our 21. And then we multiply 3 by something to get there. If you don't already know, we can do 1, 2, 3, 4, 5, 6, 7. 3 times 7 got us to this 21. We do also need to remember that we have 2 place value holders to get that 21 into the correct place value. So we will need 2 place value holders to get our 7 into the correct place value as well. Don't forget to balance out your zeros. So since we had 2 zeros over here, we also needed 2 zeros over here, which is, so we're really doing 3 times 700, not just 3 times 7. Once we have that, we're going to go ahead and subtract that out. And then we are left with 92. Now again, we have another dividend that we can start all over with. So we are going to look again at the largest place value. Let me get it. We're going to look at this largest place value again on our new dividend, which is now 92. And we're going to say, how many times can 3 go into the digit 9? We know our 3 multiples. So we know that we can do 3 times 3 to get to 9 right here. But again, this 9 is not in the ones place, it is in the tens place. We need our 1 0 place value holder here. So we're going to put 1 0 place value holder over on the other side as well. Balance out the zeros. And then we are going to subtract to get 2. Because we now have a new dividend of 2 that is less than our divisor of 3, we cannot do anything else. We are done with the dividing process for now. So this is just left over. We can't do anything else with it. It is our remainder. So we have a remainder of 2 for this problem. That's just the remainder though. We still need to find out what our actual quotient is. In order to find out what the whole quotient is, we need to take our 3 different parts of the quotient. So we took 3 different amounts of groups of 3 out of our dividend to see how many groups of 3 altogether we could take out. In order to get that total number, we need to add the 3 parts of the dividend. I'm so sorry, the 3 parts of the quotient to get the whole quotient. So if we add all these together, our answer is 2,730. So just pop that bad boy right in front of the remainder. We have 2,730 with a remainder of 2 because we cannot forget about this value down here because that will change a correct answer into an incorrect answer if we forget about our remainder or what's left over. So now that we have come up with a whole quotient, including the remainder, we need to assess the reasonability of that quotient. So we're saying that our answer should be 2,730 with a remainder of 2. If we look at the estimate we'll know if it's a reasonable answer because it'll be somewhat close to the estimate. We estimated that it was going to be 3,000. So because this 2,730 remainder 2 is pretty close to this 3,000 estimate, we're happy with that. That is a reasonable answer. After that, we can then check our work and then make sure without a doubt that it is in fact correct. So always check division with multiplication. So come over to the other side of your paper or wherever you can. If you need scrap paper, that's fine too. You are going to take your quotient and then multiply it by the divisor. So we'll do 2,730 times the divisor of 3. In order to multiply this out, we're just going to start with our 3, multiply that by our ones place, 3 times 0, and then we, using the partial product method, because we have not gone over standard algorithm yet, we'll just keep multiplying every single place value over until we don't have any more values left. So we'll have 3 times 30, 3 times 700, and then 3 times 200. So sorry, 3 times 2,000. Luckily for us, we already have our tic-tac here, so the multiplication's done. We just have to account for the zeros to put those digits all in the correct place values. Start here for spacing purposes. 3 times 2 is 6. And then 3 zeros, need to keep that in the thousands place. 3 times 7 is 21. 2 zeros here, needs to have 2 zeros over there. And then 3 times 3, we have 9 with our 1 0 here, 1 0 there. And then 3 times 0, definitely 0. Add all these together and we are left with 0 here, 9, 1, and 8. So we have 8,190, but we also have this remainder of 2. So whenever you have a remainder, when you're done with your multiplication for the checking part, you just add that remainder on. So we are left with 8,192, which is the dividend that we originally started with. So by checking with multiplication, before we turn our unit assessment in or our formative that we're going to be taking on this Thursday, we will already know that we're turning in a paper with 100% because you guys can check all your work so you know that it's correct. Okay. For your homework tonight, if it's taking too long for you to do, if that homework is taking you longer than, I would say, 25 problems, I think you guys have 5 problems left to work on that we didn't get together or didn't get to do together in class. If it's taking you longer than 25 minutes, please just stop, come see me in the morning, and I will work on those problems with you. Your homework should not be taking an extremely long amount of time. If it is, that just means you need some extra help. If you do, that's fine. Let me know, because I'm not going to know unless you come and tell me. We have this whole week that we're going to be practicing division. So if this is still a little bit confusing for you, that's okay. We have many days of practice ahead of us. So don't worry, we're going to get you there. If you're a parent and you still have questions for me, please feel free to email me, call me up at the school. Let me know. Okay. Thank you so much. Have a good night, guys.